Well, hello Cinemeric Nation, and welcome to Simply Cinemeric Live, a YouTube live series concentrating on key features and functions of the Cinemeric control, as well as a lot of tips and tricks that'll really apply to any CNC. I'm your host, Chris Pollock, and this is our Virtual Technical Application Center. So thank you for joining me. Today is actually the second of a three-part series that looks into how to really set up and utilize angular heads on a 3-axis machine tool. So the first series, or the first episode, really concentrated on a basic product overview. So it went into the features and functions, but didn't really have enough time to delve into the actual process of setting up. Today, that's what we're going to do. So we're going in and we're going to take a look at setting up the Big Kaiser AGU 90 adjustable head, or sometimes referred to as aggregates. Now, this head is unique because it allows us to actually rotate the tool orientation anywhere within 360 degrees around our Z-axis, and also adjust our tool orientation from 0, that would be pointing straight down, to 90 degrees horizontally about my Y-axis. So fundamentally, I can take a simple 3-axis machine tool like we see here today and really convert it into a basic 5-axis kinematic. Now, the other two rotaries are obviously manual, so I would have to adjust them as I want to use them, but I can, for all intents and purposes, make this into a low cost effective 5-axis machine tool. So how do we do it? How do we set up this functionality, digging a little deeper into the setup process? Well, first step always, whenever you're going to change anything in a control, you want to make sure you have a good solid backup of the system. Without that backup, God forbid something happens, you may find yourself in a position where you cannot get the machine back up and going again. A lot of us in the industry like to call it turning the machine into a toaster oven, because that's about as functional as it would be. So a quick, simple way to make sure you have a current backup before you ever proceed any further is you want to put a USB stick into the USB port, and then right off the machine's control panel, I want to press Control, Alternate, and S. And think of S as system, because that's what it's doing. It's doing a system backup. So right now, it's going to really take all of the data, it's taking and making like an image file, and writing it to the USB stick. Now, there's certainly a longer process that gives you a little more control that can be done under the setup screen. We've gone into that in quite a bit of detail in our service webinar, so you can always reference that if you want to get into it. This here is just a quick, simple down and dirty method. As long as you have a USB stick and a keyboard, you can use the same process on any of the Cinemeric controls. So once it's done backing up, you're going to get an archive has been finished successfully. That means you're good. I can say OK, and we can now remove the USB stick. We are done. We now have a safe backup, and it's not in the machine, it's external. And I'm always a big advocate whenever I do backups to have them externally of the machine, just in case something actually went wrong. Okay, so we've now created a backup of the system. So how do I turn on the feature or the function? You'll notice currently I don't have a swivel button displayed. It would normally be displayed in my lower right-hand corner. And the same thing in a part program, I'm not going to see the swivel functionality in the part program yet, because my machine parameters haven't been set. So how do I set the machine parameters? Step one is going to be going and navigating over to our setup area. So we're going to bring up a little display and show you the machine parameters we're going to take a look at today. Now, we're not going to go through and set every one, but I do want to highlight some of the key feature functions or steps you would go through when actually setting machine parameters. I will give you guys a list of this in the on the description of the video, so come back and check the recording later. You'll get at least this list of all the basic machine parameters that should be set. Additionally, please comment about these videos. If you like them, please like and follow the channel, and also let us know about the timing and the format that we're doing, what you kind of think about it. This is a brand new series for us, so we'd like to get your feedback. Right now we're trying to do them around 2 p.m. Eastern Standard Time. I am on the East Coast of the United States, but if you think that there might be a better time that most people would be available, please enter them into the comments and let me know. I'd love to find out what you're thinking. So I want to navigate over to the machine setup area. I'm going to hit my menu select key, and I'm going to choose the setup key. And that's going to bring me into the basic setup or parameters area of the control. Now I'm going to look for the machine data button. If you don't initially see it, you may be one level in, so just use your gray arrow on the left side of your monitor to back you out one screen, or you can use the arrow to the right to change your horizontal soft keys over until you find the machine data button. Once I found the machine data button, now you're going to navigate through machine data parameters. Those are parameters that have an MD designation. Or you could expand over and go to system data parameters. Those are parameters that have an SD extension. So for us, going down the list, the first parameter would be MD 10602. So I know that's a general machine data parameter because it starts with a 10. And then from here, you can just use your simple start function or search function, shall I say, type in the machine parameter. So 10602, we'll search down to that one. And now I'm going to go and start typing in the parameters as recommended by our reference right here is what you have on front of your screen. Now, it's worth notating what is stated just to the right of the parameter. So you see how there's a PO just to the right of the parameter? That designates that this parameter is a power-up parameter. So if I was to change this parameter right now to make it active, I would have to reboot the system. As I go through and search down through the parameters, you're going to see some will have maybe a reset or an RE command. That means I have to hit the reset button on my front panel to activate that. I may have a CF command. That means that I simply need to hit this soft key, the set MD active CF soft key, to make that active. So pay attention as you step down through the machine parameters, because what you have to do to make them go effective is based on this. So if any one of these parameters had power up, which our first one did, I would have to cycle the power. Now I've previously set these just to keep things moving along. On your machine, you would probably have to actually enter the value. Now the next thing I want to look at is 18088. In 18088, you'll notice it's designated as an 840 only parameter, 840 DSL. So the 828 is going to have a little less functionality than its big brother, the 840 control. So with that, if you come down to a parameter on the 828 and you see that it's grayed out, there's a couple things you want to ask yourself. First, do I have the correct access level set in the control for entering these parameters? So you would at least want to be at a service access level. So you'd want to put the service password in, or you can put in the manufacturer password. So here I see I have the manufacturer password entered into the control. So with that entered, I know it's not a password protection area. So in this case, I am just not allowed to set that parameter on the 828. I would be able to on the 840. And this parameter happens to be telling us that I can only have one carrier or one record set active in the 828 control. So it's a little limiting, where on an 840, I can switch between a bunch of different parameter sets. So that you're going to see when we actually set up the swivel mask. Now there are some machine parameters that start with the 2 or the 20,000 series. Those would be channel MDs. If I come down to 52212, I see that this parameter is what we call a hex bit. So any parameter that has an H to the right of it, that means that it's a hexadecimal value. So it's going to really incorporate a lot of different capabilities within the same parameter. So we've given you a viewer by hitting the select key, which is your blue horseshoe key in between your 4 blue arrows. I can come in and I can actually see all of the bits that make up a hex bit. So in my case, I needed to make sure bit 0 and bit 3 were active. So I'm going to check bit 0, bit 3 happened to already been active. If we tell you a value of 1, that means we want the bit high, or we want a check mark in it. If we tell you a value of 0 for that bit, then I would uncheck or unselect that. And by saying OK, the system will then calculate out the appropriate hex bit for that value. You could also use an external hex bit calculator and type the hex bit in here. Now you notice this parameter happens to have an IM. It's immediate. It's the only one I've changed. So right now, if we come out to the jog screen, you'll see we have our swivel button now located in the lower right-hand corner. And that is certainly step 1 for getting this function set up. Now, there's a lot of other stuff I'm going to need to know. So I'm going to have to go in and really kind of go through and measure some mechanicals now on the machine to figure out where this rotary head is in space. Now, before I did anything else, I did create a mount here. I'm going to jog down a little bit. So you will have to do some mechanicals on these heads. They give you a little datum block, but the block does have to be mounted to the physical machine. So I made this block that located off of some bolt hole patterns on my spindle cartridge. Pretty common way to mount these, or you can make an extending block off the spindle flange or come off the head. But I need to have some way of being able to put this head in and out of the machine and have it locate the same point at all times. So that's what this block is going to give me or allow me to do. So what I did was I made sure when I machined this block and I set it up that when I had this scale set to 0, that my spindle itself was straight or aligned with the x-axis. So I would have indicated it straight, and I made myself a little bit of adjustment here so I can basically tram in the head. So that was setting my base 0 location. So once I've done that, and I mechanically got the head physically in the machine spindle, now it's time to actually find some of the key numbers I'm going to need to know. And what do I need to know about this? Well, when you're setting up these type of heads, you do have to set up the machine with what we call a positive tool length offset strategy. So what that means is my tool lengths will be measured from gauge line of the spindle or spindle face. I commissioned this machine to be spindle face to the tool tip. Now, in a right angle head application, I need a couple extra components. I need to know my gauge line to the center of rotation of this first rotary axis. And then I can potentially also set a value from here out. So I've set the machine up in an orientation, and before I go any further, I do want to always make sure that the machine is sitting square, that the head is square, that I don't have any mechanical issues that I'm dealing with. So step one, we're going to put a standard, this is just a piece of ground rod, into my collet, and I'm going to make sure that this is sitting and the machine is straight. So I want to check two things here. I want to check for concentricity and I want to check for parallelism. So when you're using an indicator on this type of application, it's worth notating that I have to find the high spot of the bar first. I want to set my indicator dead center of this bar. So if you just start to engage on the indicator, and now I'm going to move the perpendicular axis to the bar, in and out, and what I'm looking for is I'm looking for the high spot, and I'm into it quite a bit, so I'm going to bring up my Z a little bit. Because what I'm looking for is I'm looking for the highest point before the indicator drops. So I don't know if you guys can see that. I know it's a little hard to see the indicator from that orientation, but my needle is maxing out. That's finding the center line of this bar. Now I could check for run out to make sure my bar is not running out. So I would want to spin my spindle, right? I want to turn it and make sure my needle is holding a straight point. And then, and I'm just going to move down to a 0 mark, I would now move the x-axis back and forth and make sure this is straight. Now, it's important to know that this is physically straight on the machine. If it's not, I could have another mechanical issue. It's probably not necessarily something I would want to compensate for in the head. So if this whole column was tipped up and not running parallel to my table, that could be an issue. Now, what I've previously done as well was I did the same process, but on the side of the bar, and I came across and I indicated to make sure the head was sitting basically parallel to the X. And if not, I can then adjust this head, this rotational head, by unscrewing these two bolts and basically tramming the head in until I got a 0 mark on the side and I'm 0 on the bottom. Once I've done all that, now it's time to find some geometries of this head. So here, if you look, I'm sitting at a 0 point, all right? We'll bring the indicator over a little bit, or the camera. I'm sitting at a 0 point on my spindle, and basically I'm off center line of this axis. This axis is sitting at 0 degrees, or full 90. So I'm off center line by the radius of this dowel pin. This dowel pin, or this ground rod, is 3/8 of an inch. So that's 3/16 or 187 off. So what I want to do is I want to set a temporary 0 there. So load up a work offset, something that you don't mind rewriting or overwriting. Go to our set work offset and set the Z-axis to be half of whatever your standard is. So 1875 And if we did the math, I can show you that, 0.375 divided by 2, right? There's your 1875. And this is, I'm in a plus value. Because what I'm saying is, if I was to move the machine, all right, so we can do it right now. If I was to move the machine down to 0, when I get to 0, I'm sitting at the center line of this axis. And this is our first step. Now then what I have to do is I have to measure from center line to my gauge point. So really what I would do is I'd remove the head, but for time's sake, I'm just going to give you a quick demonstration of what I'm talking about. Imagine the head was physically removed right now. I would bring my indicator over. I would bring my head down, right? And I bring it all the way down until my indicator physically hit my spindle face or my gauge line. And I would run it until I'm sitting at 0. And now the distance on my display would be the distance from gauge line to center of rotation. So we previously measured that value, and that value was measured in at 7.0838. So that's an important number. So I wrote that number down because I need to know that value. So now step 2 in getting my dimensional values, and the manufacturer of these heads will give you these numbers, but you're going to want to at least double check them, because depending on how accurate those numbers are when they gave you, or you can just simply measure them on the machine. That's certainly going to be the best scenario. Now the next step is, and this is going to depend on my physical head design, but I can set up a secondary value from a datum off the face of this secondary spindle to the center of rotation. Now, if I have a quick change unit, I'm going to absolutely want to do that. This one doesn't have a quick change, it's just an ER style collet. So if I have a stop here and I know I want to be able to repeat tooling and I want my offset to be the projection out, then I can do this step. If not, I can actually leave this step alone and let this total distance be handled in the tool offset. I'm going to show you how to do it the other way. Now, before I take that measurement, what I am going to do is I'm going to change out my tool. So I use this standard, this ground rod, just to be able to make sure things were square. But my next step is actually putting in a tooling ball into the spindle. Okay. And what that's going to do is that's going to allow me also to verify or validate these values, these numbers, once I'm done them all. So just to show you guys, this is a standard 3/4 inch diameter tooling ball that I'm using. And what we'll be able to do is we'll be able to actually rotate around this ball and verify that our function is tracking properly. So we're going to swap out the ball right now. We're going to need it in a little bit, so I might as well swap it out while I'm in a horizontal orientation or a 90-degree orientation. And now what I'm going to do is I'm going to swing this head down. So let me get the indicator out of the way, because it's important. It's important to make sure I do not bump that indicator during this process. If I change the position of that indicator at all, then my measurement's going to be wrong. It's going to be inaccurate. So here we're going to loosen it up. So to adjust this head, you loosen up all 6 bolts around here, front and back. I already have these loosed just for time's sake to speed things up for us a little bit. And then I'm going to move down the head to a vertical orientation. And then we bring the appropriate indent in. And we went through this in a lot more detail certainly in our first video. But now my head is straight. And certainly if I was going with real hard numbers here, I would make sure everything's tight, everything's settled in before I take any of these measurements. Okay, so now the next step is I have a 0 set the center, right? Remember, we had that 0 established. So if I move the machine over quickly and I bring the head down, just going to eyeball it to the center. You can see we're basically at 0 is the center. So now I'm taking a measurement down to this collet face. Okay. So we bring our Z down. There we go. And bring it right to 0. Okay. Now I want to write down the dimension I see on the display. So I have a value of 3.9508. We're going to write that down, because this is an important value when doing our setup. Okay, so now we know these two numbers. It's time to set up the swivel cycle. I can't really go any further at this point until I do set up the swivel cycle, because I now need the swivel cycle to compensate for these values. So what we're going to do is we're going to jump back over into the display, and here we're going to navigate over to setup again. So I'm going to go menu select and setup. I'm going to back out of my machine parameters, because I'm going to expand my horizontal keys over with my gray arrow to access the swivel data record. And this is the area that allows me to set up these values. Now this is just a GUI. This really is designed to then write to system variables that are called tool carrier variables, or TCARs, a lot of times we refer to them too. So what I'll do is I'll show you how to do a save data record, and then that's going to make a backup file. But this is writing directly to it. So what we'll do is now we start to fill out the table. Now, the first thing in the table we have to fill out is a name. So I'm going to call mine the AGU 90, calling it after my Big Kaiser head, but you can give it any name. This is for your own reference, but this will also be the name that's displayed when you select the swivel cycle. Then I need to make sure I tell it the kinematic type. So since both rotaries are being handled off the spindle, this is what we would call an inclinable head. So I need to pick the inclinable head option. Now the number record number 1, that reference to that 840D only parameter we showed you before. If I'm on an 840, I can have a bunch of these records, and I can, tool change between maybe 10 different right angle heads if I wanted to, with all different kinematic types. On this machine, I can only have one because it's an 828, so I'm just going to leave that value to 1. I do want to enable the swivel cycle. It's going to allow it to do what it needs to do, so certainly I would set the flag to yes. And then I pick, or I choose my retract strategy if I want to allow the machine to retract for swiveling. So a no retract would mean the operator wouldn't have any selection, but then you can select a Z only and right up through a Z incremental direction or a ZXY shift. So you choose the one you want. The way I got this table up, on any variable where there's, or selection where there's a bunch of options, hit any key you want, doesn't matter, we'll give you the table. Now I tell the machine where I want to go in relation to the machine coordinate system for the retract. So my machine 0, is the top of its travel. And now it's time to set up first the vector type. So this is what tells us the type of kinematic we have. So in my case, I have a axis 1, it's what we call the carrying axis, that revolves around my Z. And since it's up in my head, it's going to become a value of 1, and it's a positive value. If the rotary was down in the table, then it would be a negative value, a negative 1. So that's telling me my first rotary is sitting up in the head, and it's also about the Z axis. Now in this case, if you look at mine, my second rotary rotates about the Y, right? We use our right hand rule. We look at our old right hand rule, and we can see that the secondary axis rotates about Y. So we want to come in and put a positive value again, because the rotary is up in the head, a value of 1. So bare minimum I have to do, that stipulates the vector direction of our rotary axes. Now I want to give it a couple joint offsets. So remember, I measured a value of 7.0838. So I'm going to plug this in for my first offset. So anybody that's messed around in this type of setup before may have noticed or remembered that you always close the vector chain, right? So you might have two different joint offsets and then the inverse of the joint offset. When you're doing a head-head kinematic for this type of configuration, you don't actually close it. So we're going to leave our top vector at 0, this vector I1. But my I3 is what's going to handle my 3.9508 value. Now I do need to go into the rotary axis table. I need to define what my axis definer is going to be. So this is just the selection, or what I view. So I'm calling my first rotary C. You can call it anything you want. I want to make sure I select it as a manual axis. I want to give it the travel, so that's a 360-degree traveling axis. I can spin all the way around. My second, or my carried axis, what we mean by carried is if I move C, the other one's going to move with it, is going to be my B axis. Again, manual, so this will make sure that I prompt to do a manual change, and I'm going to give it 90. And the sign is critical, so think about your right-hand rule when defining the direction. If things are going the wrong way, you may have to flip the signs here. The rest of the table I would now fill out, and there's just some options. So tracking I can't use. That would be if I had a machine with full 5-axis simultaneous motion. But I can give it rotary axis direct programming. I want to make sure that I leave my direction reference selection to a no, but displaying positive. And I want to use an automatic swivel data record and automatic tool change, because you're going to handle the tool change to the tool change macro anyway. Once we've filled out this table, now if I come back and I come out to jog, you'll see we get the swivel table, and now it would be usable. We have the name, we have some offsets. So really it should be functioning at this point. So the next step would be probably saving the record. So if you come back, as you start to work on this, as you start to change things, you might want to make a backup of it. So that's the save data record. These values are live now. The only thing saving the data record does is it actually creates a part program in the part program memory named whatever the name of the carrier was. So there's my AGU 90, and these are actually the variables that got written to by that cycle. So with these variables, if I wanted to, if I maybe made a change or affected something, if I want to reload all these variables, I can run this as a part program in auto mode. And then if I go back to here, had there been any changes that I may have made, that would update them. So that's a quick way for you to make a backup of the system. But really at this point, we can now check to see if we've done a successful setup. So how do I check the rotation of any axis? And this can work on a full 5-axis setup. But what I do is I use a tooling ball. So what we're going to do right now is we're going to set up an offset. But first things first, I want to set a 0 up at the point I'm at right now. But I need this 0 to take into account now the kinematics of this machine, my 2 joint offsets, right? My 7.8 and my 3 point whatever it was. So come into swivel, swivel the machine. It can be, I can leave it at the 180 or at 0. I happen to be at 180, so I'll leave it there. The big thing is I put the Z or my B at 0, pointing straight up and down. I want to activate the carrier record. So by cycle starting twice, first activates and tells me where to move the rotaries. Second, I would move them. I now see that the carrier record is active. I have a simple rotation about Z because I only have a 180 orientation about my C axis set, but it's now taking these offsets into account. So once I've activated the record, now give yourself a 0 point at this location that we're currently sitting at. So let me switch back here for you. So I'm still sitting at my column face where I took my measurement before. I've now set a basic 0 there. So now I'm going to move down and find the center of the ball and set my tool length offset. So bring your axes up. The same process as before. So we want to move the machine in rough center, bring the axes down, and now move your 2 axes to find the middle of the sphere. So I'm just jogging it until I get to the high point, finding the basic center. I'm now going to move the machine to a 0 point, right? And now we're going to set a tool length offset. Now typically I would just set a tool length offset right here, but when you're doing a tooling ball check, I actually want to work from the center of the sphere. I want to work from the middle of it. So instead of measuring my tool and measuring my length and telling it I'm at 0 now, I'm going to tell it I'm at half of my ball diameter. So I have 375 entered in this page because it's a 750 ball diameter. So I hit set length, and the system then calculates a value of basically a ½ an inch. So if I was to do a quick measurement from this face to the center of that sphere, I would buy that that's a ½ an inch. So now it knows the tool offset. Last step in this check is to reset your z-axis coordinate system to 0 now, because I want to be able to come back and repeat back to this point, and I want to set my x and y 0, 0. Okay, so now it's time to see if everything we did is going to start to function or work. So what I'm going to do is I'm going to rotate to a new orientation point, and I'm going to do it through my cycle 800. So I go to swivel. I'm going to maybe send her to a b-axis of 30 degrees. And maybe we get a bad connection here, of course. Bear with me one sec. Oh, there we go. Good. Got it back. Don't know why that was. Okay. So we're going to set our angle to 30 degrees. So cycle start. It's going to prompt me to move the machine to 30 degrees. You see the display changes because now the system, I'll give myself a little bit of room to get in here. Now the system is now compensating for the ball being over to the right somewhere. So we'll come in, we'll start to move it to 30. I do have to get my cheaters. Gotta love getting old. All right, so that should be pretty close to 30 degrees. There's a scale here on the bottom. Let's try to bring in the 0. See if I'm close enough. And if you're not, when you start just turning this in, it will get tight really quick. It should be nice and free until the bottom. You don't have to crank on this thing. Okay, so we're sitting there at, and let's get you a little closer. We're sitting here at 30 degrees. Now we're going to position, and this is why I set that secondary 0. I can just position to, 0, 0 for all my linear axes. Cycle start. And where the machine should end up is if I was to draw a theoretical line from the center of the severe straight down to my indicator, that's where it should set. So I don't know if you guys can see it, but I'm within a few tenths of where I was at. So what I would want to do then is repeat this measurement for a couple different angles. So I'm going to go right to the extreme. We're going to roll right to 90 degrees. So, but I would use a couple. I'd probably do 60 and then 90. But let's bring her right out. Give me a little bit of room here. Bring her right out to 90 degrees. And we are there. Swing it up. Get the scale close. Tighten her up. We'll give you a little bit better shot. Now, remember, I need to reactivate the orientation through the swivel cycle, so she'll compensate. If I was on a full 5-axis machine, I could actually do this dynamically and watch the indicator roll right around that sphere. But it's really the exact same process as I'm showing you today. Now I can position, and if you ever want to check any rotary axes on a 5-axis machine, this is a quick, nice, simple, down and dirty method. You should always be able to track that sphere. So always remember, you're going to work from the center of the ball. There we see, I don't know, maybe 4/10 over. That's pretty good. Certainly, you know, I have to keep in mind the positioning accuracy I should expect with this type of setup. But I would say if you can stay within, you know, a thou or so, that's doing really good in this scenario. And then, you know, if you wanted to, you can get much more accurate methods. So this is basically the initial setup for getting it to work. Now I do want to show you guys, there is one other scenario that you have to be careful of. And that is the concentricity or run out of the C-axis, not necessarily the spindle. So if I was to bring my head up, all right, and I'm going to swing the spindle back down. So let me move this out of the way a little bit. One of the things that's extremely common in these kind of heads, that's to actually be expected, is the fact that as I rotate the C-axis, it's not rotating concentric to the Z-axis or my spindle. It's actually going to run out. Now, because of that, as I induce any rotational moves in my C, it would affect that tooling bolt check. It would not continue to be accurate the way it is as I move my C around. So what you want to do is you want to always make sure that you know what kind of run out you have, and then you can start to compensate for it right in the swivel cycle. So I'm going to bring over my tool. So the difference here is now I'm coming down to the side of the sphere, same way I did before, but now I'm working off the side of it. So again, find my high point. Now I'm finding my high point in X, pretty close. I'm going to bring my Z down, find the high point in Z, right about there. That's good. Now I want to just set my 0 and my Y. Okay, perfect. And then what we're going to do is we're going to loosen up this other axis point, because I'm going to now rotate the C. Keep in mind, I haven't rotated the C up till now because I previously squared this up for time's sake. So if I was going to do that tooling ball check at a bunch of orientation points around C and B, this would have to be compensated for. So if you watch the indicator, let's see if you guys can see this a little bit. I know it's kind of hard, but if you watch the indicator, I'm at 180 now. So if I rotate around, go to 0, I actually have 2 thou of run out. And as I go all the way around my 360 degrees, I'm getting run out. So what you want to do is you want to first check it in one direction and then the other direction. So check it between 0 and 180. And what I would say is set the indicator to split the difference. So you want to be going in either plus or minus. So if I got a thou, I would move the machine's axis to be on one side of it. So I want to make sure that, I put it basically about a thou here, and I go to the other side, and we're a little bit more. So again, keep splitting the difference until I rotate back and forth. And that's going to tell me half of that value, or what I'm seeing, is going to tell me how much I need to compensate for. So it's basically right around a thou, maybe a little bit more. And then what you're going to do is you're going to come back to the swivel data mask, and you're going to now enter these values in the offset I2 vector, because I'm compensating for where the center of that rotary is. So to give you an example, I'm going to plug in 0.001 here right now. Okay, so now when I come out, I want to set my swivel axes to 0 and 0. That's where I'm setting right now. Cycle start. And let's set a 0. I didn't set a 0 here. I want to set a 0 before. We can reset that. Okay. Just a quick 0 mark for us. So now when we activate the swivel mask, now if you notice the numbers, as I swing my rotary around, the system is then going to offset the physical axes. So if I were to then command the machine, remember this is a static, this is because I have a basic manual axis, but if I command the machine now to move to 0, it will then compensate for that run out. So you're going to end up plugging in a value, plus or minus. You're going to have to, measure it and figure it out. But we're going to plug in a value in this I2 offset vector. And if you get everything perfect, if you keep repeating to 0, your indicator should keep going back to 0. Anywhere without around 360 degrees. And then re-add in your rotary axis. So the only last thing I want to show you real quick, and then we're going to wrap up here, is what we call our Cust 800 cycle. And what happens here in the system is, right now we're working off of one that I've already created, but the system has a cycle that gets called up every time I do a swivel cycle. Okay? And it can be found back in the setup area under system data, and it's going to be under NC data, under Cycles, and you're going to find it in the Standard Cycles folder. And this is what we call our Cust 800. So if I need the system to do anything unique other than the out-of-the-box settings, I'm expected to copy this cycle or this file and plug it up into my manufacturer or user folder. I happen to put mine up in user. And then I can now edit that cycle. And this keeps you from changing the one that we've already built in standard. Now, once you've copied it up, reboot the system once, and now it's going to start using the one that's in the folder above standard cycles, so in my case Cust in user cycles. Now what did I do? Well, I actually came into this cycle and I went down and I made a change into the cycle. So you can go down and kind of follow the system through in different areas of the macro, but I wanted to change whether the system prompted me and waited for a rotation when I was simulating a program. When I first set this up, it was pausing every time I simulated a program and asking me to do a rotation. But I don't need that in simulation, I only need that in auto mode. So I was able to go in here, find the area that was being called during that process. I put some conditional statements in to say, hey, if you're in simulation mode, don't do that, just continue on with the program. So a lot of stuff can be done inside of here. You know, this is where a builder would put in washdowns for rotaries, all that kind of stuff would be within the Cust 800 cycle. So I just wanted to give you a brief exposure to it. Certainly there's a lot in there. So if you guys get into this type of functionality, you're going to want to dig into that a lot deeper. And with that being said, I want to thank everybody for showing up and joining us for another one of these YouTube live events. Like I said earlier, if you like it, please show us that you like it by liking it. Follow the channel and use that little bell, and that'll give you an indication the next time I have one coming up or when I post another one. We are going to be doing a part 3 that gets more into the operation side, actually building the tools and going through and adjusting the orientation. So we are going to talk about that next. And you know, let us know what your comments are. We'd really like to get some feedback from everybody. I'm going to take a look. We got a couple questions and comments here. What's the advantage to do this instead of tramming a single plate? So I'm assuming they're talking about tipping the part up on some kind of trammed plate like a sign bar or whatnot. The beauty of this setup right here is I can adjust it to any orientation, and I could adjust it mid-program if I needed to. So in the previous one that I did, I had a couple different orientations and I moved it during the part program. But really, if you think about it, just speed of setup. How quickly am I able to change the orientation of that tool without having to move my entire part? And then I can work on that given plane. You know, everything has a benefit and has its place. Really the thing here is to show you guys and expose you to some of this technology. Another comment. So it was a good question or a good point from one of my colleagues. When building an archive, it is always good to have a clear spindle when you make that backup. Some machine OEMs are much more critical on that than others. So what you would want to do is do a tool 0 to clear the spindle before you actually make the archive like we showed you earlier with the Control-Alt-S functionality. Again, I'd like to thank everybody. My name again is Chris Pollock. This is Simply Cinemaric Live, and I look forward to seeing you guys in the future. Have yourselves a great day.